So today we will be mainly focusing on the copper interconnection we have in a few of our panels. But today we will be mainly focusing on the big panel, the 72 double glass panel, which is the Gen 3. So it's good to highlight maybe that we have implemented what we call it the infinite technology in this panel. So this is not a new technology. We did it already for the small panels last year for the 54 cells. And we also now doing this for the rest of the panels and like the 60 cells and now the 72 double glass. So if we look to the power of these panels, you can get nowadays 665, 670. And by the end of the year, we're gonna increase another 10 watt on the top of that. And if we compare it to our previous generation, it's like the 650, 655, we can see that we improved the power by 20 watt, which is almost a 3%. And if we compare it with the with the mainstream products, mainstream panels in the market, normally based on the TopCon technology, which is like 620, 630. I started to see a few 635 coming soon. So we have 40 watt more. Yeah, just to highlight, I'm talking about the regular dimension of these panels, the long ones, 2382 by 1134. Normally, these panels can fit ground-mounted projects, rooftops as well. These panels comes normally with short cables and AIKO connectors, unless you have a special order, so you can customize and get long cables and Stobli connectors if you need so. So I think last time we run this panel and we focused more on the infinite technology, how we do it, how we improve the power output. Also, we focused on the anti-ignition of our double glass panels, how we achieved it with TÜV. And today we're gonna mainly talk about the copper interconnection and how we upgraded the material and the process to enhance mainly the micro cracks issue, like to have micro crack resistance panels and also increase the yield. Also, I would like to emphasize that these panels have the basic features, I will call them, we used to have for the last 2 years. So we're talking about the partial shading optimization, higher temperature restriction, the micro crack resistance, lower degradation, and also the lower temperature coefficient. So all these features are included in this panel, and we can offer it as well. As you know, when we talk about the solar industry overall, we have an issue with the silver shortage. So if we look together to this graph, we can see the supply and demand overall on silver. And we can see that the demand is already higher than the supply. That's why they do a lot of recycling for the silver in order to match the demand. Also, we can see the PV demand, where you can see the gray line, which is growing or almost getting steady for the last 3 years. So we need around 6,000 tons every year of silver I'm talking about the whole solar industry. So considering the continued rise in the mining cost and the growing industrial demand, the supply shortage is likely to be worse even in the future. So this is the first challenge we have in the solar industry. The second challenge, which we started to see recently, I would say in the last 6 months, I think from end of August last year, the price of silver ounce started to crazy increasing. So we have seen a significant increase, like from, we're talking about 30 USD per ounce to it hits, I think 3 4 weeks ago, it hit 120 USD per ounce. Now the price is slightly tanked, and I just checked this morning. It's around 80 US dollar, which is still almost 3 times than the previous price. So these two things, like the shortage of the silver and the high price of silver, is causing a significant volatility in the module prices, and also there's a high level of uncertainty in the module supply. I would say like AIKO had kind of projection for the silver issue, and it's a common issue in the whole industry. But I would say AIKO, one of the leaders who took the step technically and to commercialize a product based on copper. So we started to do this development 4 years ago, and I would say using the copper will give us the copper interconnections on our panels will give us some value. So we talk about stable module pricing, where the copper has significantly greater market availability than silver and more stable pricing. And also we talk about reliable market supply. So we have sufficient raw material that ensures the stable production and reliable on-time delivery of our panels. And also we talk about overall better performance. So the advancement we have, like in the material, I mean, using copper instead of silver, plus also the improvement of the production process, we're gonna run through also this part. This enhanced the microcrack resistance in our panels, and also improves the energy, like the energy output you get out of the solar project. So it's a big development, and I see other manufacturers will start soon investigate this approach, and try to replace the copper, try to replace the silver in their panels. But the positive, sorry, yeah, the good thing that AIKO has a positive position, that we started this process almost 4 years ago, and we have yeah, we have the lead, I would say. When we talk about, solar panels, it's very important to secure the project to produce energy as per the study, as per the expectation, in order to match, the power purchase agreement, the return of investment, and the feasibility study of your project. One of the big risk we have seen in the last decade is the microcracks, and even we call it, like the technical guys, the invisible killer of the photovoltaic power plants. So just to highlight, having microcracks could cause fire hazard. This is the worst case scenario. The panel could catch fire, and the fire could spread, and basically you lose the PV project. There might be also power degradation, so the panels degrades faster with these microcracks. There might be also circuit leakage in in the current, I mean, and also crack fragment formation. So having micro cracks in the PV project is something everyone wants to avoid, because basically you increase we call it the OPEX, the operational cost. You need to change these cracked panels, and if you don't do so, the energy output, the yield will drop significantly, and then you impact the business case of your project. So this is a big advantage of using the copper. It will enhance the micro cracks. How we do it technically, here you can see that I would say the whole electrical circuit of on the cell level is made out of copper. So we have copper grid lines and copper ribbons. Unless like TopCon and heterojunction, I'm not sure if PERC is still available in the market, but these three technology of the different cells I mentioned, they use silver instead. And yeah, silver is more fragile and more keen to to crack because the panels normally they are shipped from China all the way here. So there's a big potential to have pressure during the shipment, also during the installation, during also when also due to the snow load or wind load. So the potential of having micro cracks is always there, starting from the whole journey when you manufacture the panels all the way to install it on the site. But yeah, the good thing of using copper that you can mitigate some way how the micro cracks. Um, the development we have done and our panels can be, I would say, summarized in these upgrades. First one, the material. We use silver. We used copper instead of silver. Also, we upgraded the process where we call it the copper electroplating process. And it's unlike the silver sintering, because the sintering of silvers is causing heat dissipation, and this heat affects the wafer, basically the cells, and has a negative impact on the long term, and the energy output, the yield will be affected as well. And also we upgraded the soldering process, because we our cells is based on the back contact technology. The soldering can happen all the way from the back side. So when you connect these cells together to make the substrings, you do the soldering only from the back side, unlike the other technologies. When you have the electrical circuit from both sides of the cells, in order to continue the circuit, you need to make this kind of Z bridge, Z-shaped soldering from the front side and back side, and then you have more potential to have tension and cracks at the edge of the cells. And once these cracks start, they get bigger and affect the yield of the whole project. So it's always good to think about micro cracks, and yeah, try to avoid it in real projects. Um, I would also like to show you this test where we have done kind of smashing test here. So we did it for three different cell technologies. On the left side, it's a back contact cells based on copper, which is we can call it the AIKO cell. And the one in the middle, it's a back contact cell, but it's based on silver. And the one on the right is the TopCon cell. So basically, in this test, we measure the current before we do the smashing test, and then we do the smashing test and see the current after the test, and see the loss, the percentage of the loss we have. So let's have a look together. Simple as that. One hit. So you can see here the top one almost smashed completely. The silver, the back contact based on silver is also has a big cracks, and our cells based on copper has smaller. So basically, This is the advantage we have, that even if you have micro cracks, the loss will be the loss of the current will be less. So the Topcon lost almost 42 percentage. The back contact based on silver almost 30 percentage, and the one based on copper is 18 percentage. And this, will have also a big impact on the yield and the financial benefits of the solar project. Also, I would like to mention that using the copper interconnection will ensure long-term energy yield. So it's not only due to the copper interconnection, but if you also put on the top of that the other features we have, like lower degradation, partial shading optimization, all in all will push the yield. So this is one project we have monitored, like we did kind of test a project to put the panels side by side. You have the same weather condition, and we have seen that the AIKO solution can provide 5% more energy yield based on based on uh, based on the kilowatt peak. So here you can see the AIKO has 959 56 kilowatt hour per kilowatt peak. This is, we call it the specific production, and the top one is 912. So this is only 1 kilowatt peak. If you think about a bigger system, then this will be added up, and it will be a big win for the asset owner. As a summary, I would like to maybe just run through the features and the values we provide with our panels. So high power, where you can get 670 out of the standard size of the panel, which is almost 35 40 watt more than other panels in the market. This is high power due, the back contact technology, the NVZ ribbon, we call it, the zero gaps between the cells, and also the high resistivity wafer. Also, we with our solution, you can achieve higher returns due to the partial shading optimization, lower degradation, and the lower temperature coefficient, and also the anti-dust. So the anti-dust is like an optional feature. You can basically you can add it to the panels. So if you have a project in a dusty area, you can basically customize a panel to reduce the dust accumulation on the panel, and this also will help to increase the yield and improve the return of the PP project. And the third one is the ultra safety. It's yeah, the anti-ignition, the feature we have discussed last time, and in the last basically webinar, and we have a better hill strike performance. We have also the micro cracks we run through, resistance. Also, it's good to know that all our double glass panels holding fire class A according to the IEC standard, which is I think few panels in the market has fire class A. So just keep it in mind. I think it's sometimes a key for a few projects. Um, Also, we have an option to have anti-glare panels. Basically, we use advanced glass, and can reduce the glare of the sun rays. Yeah, few projects needs this feature, like when you have projects close by the ports, airports, or close to the highways, then they need these anti-glare panels. At the end, I would like to run through one business case and look to this business case from a different perspective. First time we look to the to the business case from the project owner perspective, and see how the return of investment could be if we do a comparison between like two options, like one option with a regular panel, if we use like 630 watt, let me just go full screen. So 630 watt of the panel, and the other option, if you go with AIKO panel 665, which is the available power now. And we talk about a normal system size, something around 700, 800 kilowatt peak. The number of panels are equivalent for the two options. Basically, we utilize the same space of the roof, 1,240 panels. And we can see that the DC system with the DC capacity of AIKO option will be improved by almost 5.6 percentage. So the owner basically, he will buy a bigger system. He will invest more. He will invest in this case 20 grand. But as an advantage of that, he will get 8% more revenue on the timeline of the project. So he will invest 20 grand at the beginning, like this is the capex will be increased by 20k, and he will get 156 grants, and this is due to the extra energy he can produce due to the bigger system and the other features we run through. If we talk about the payback time, also it gets shortened. So with the AIKO solution, it's 6 years, the other one 6.2, so 1 to 2 months. In some cases, I have seen even 6 months, depends on the conditions of the project. Also, the internal rate of return is slightly improved. So I would say it's like a win-win situation for the asset owner to go with efficient solution. And I think these are the features you are familiar with, that like the fire resistance is fire class A, and yeah, the rest is, I think you're familiar with. The temperature coefficient is lower. We already run through these features. So this is the one part when we talk about the business case from the project owner, the one who own the asset or the investor. And if we talk about the EPC, the one who installed the system, if they go with AIKO option, basically the efficient panel, they can increase the system they sell to the asset owner. So it's the same project, but we look from now from the EPC perspective. So they can basically sell 825 kilowatt peak instead of 781. And if we assume they sell the project on, they sell the kilowatt peak on the same price, basically they can make more revenue with a bigger system, with the efficient system, which is AIKO. So in this project, they can increase the revenue by 21k, and this is the idea behind pushing our panels. You can basically show a better business case for the end user, and this is something we can help you with always. If you have a project and you would like to do kind of analysis, do this comparison to show him that using the efficient solution will help him to achieve a better business case on the long term, we can always do that. So you can reach basically the sales guys in your region, or basically the solution guys. We're happy to do that. And yeah, the EPC as well, they can do more profit because they sell a bigger system. So I think this is all for today. It was mainly about the copper interconnection, and just review the business case one more time with you guys. So it's a short session this time. Let me see if you have some questions. Just feel free to drop it down in the chat box or on the question. I can just, let me see. I started to get few questions. So Joaquim is asking, what about AIKO ABC Gen 3 60 cells? Let me see the full question. Yeah. Will you bring them to? Yes, definitely. So these panels, like the Gen 3 panels for the small panels, 54, 60, and 72, they will be coming to Europe. It's expected to have them end of March, April time. So if you buy them through distributors, I advise you cross check with them unless you buy directly from AIKO. But I think most of the installers they buy through the channels, so you can cross check with the local channels you have, and they can confirm the availability and the power output. So you can basically design your project based on the available panels you're gonna have. Let me see. All class others, thanks in advance. And so yeah, someone is asking to share the slides. Yeah, definitely we gonna do this. Yeah, we have all the emails and we gonna send you the slides so you can review them. If you have any question, you can yeah reach us. Stefan is asking, would you using a thermal image camera to detect micro cracks? Yeah, this is something normally we do on during our trade shows. So the last one, it was an Intersolar last year. So basically, we have these thermal cameras, and you can see the difference in the micro cracks. But maybe it's a nice idea to do it with our marketing team, and then we have a nice video. So thanks for the heads up. Yeah. Going from silver to copper, so how much will lower the price? Good question. uh, yeah, I think you need to reach out to maybe to the sales guys, but yeah, because eliminating the silver will drop the price. But as far as I know, that you cannot get rid of the silver completely. You reduce the silver on the cell level, but still you have silver on the main bus bars, at the top, at the middle, and down. So it's hard to tell how much, but overall, I can see that the copper price, the panels based on copper nowadays is even cheaper than the silver one. So basically, you can get this panel, the 72 665 watt, and it's still cheaper than the 635. This is I'm sure about. But how much the price? Yeah, you need to cross check with either the sales guys or either with the local distributors. Uh, will this model be called Gen 3 or Gen 4? Chris is asking if this module will be called Gen 3 or Gen 4. So it's called Gen 3. It's basically MED72DW, like double glass. So it's a silver frame, white back sheet, and it's a Gen 3 panel. Yeah, still we don't have Gen 4. Yeah, thanks, Joaquim. Yeah, we will also have it in the 60 cells. So the infinite will be in the 60 cells, 54, 72, and 78 as well. We're gonna have a big panel with a power of 770 watt. This is mainly for the ground mount and utility projects. So just compared to TopCon, you can basically win 40 to 50 watt on the same, almost the same panel size. Maybe we're gonna have another webinar only for the 78, just to show you how you can make the best out of it. One question coming from Africa, from Muez. He's asking, is there any plan to make this module or model available in African market? Yeah, I think so. It will be available in the Middle East, like MENA, Middle East, North Africa. It will be there. Let me see. Another question from Allison. Triplets used typically and after participation. Okay. Yeah, I think Allison, your question should go to the R&D team. I don't know much about how they do the process, but yeah, I will maybe forward your email to the R&D team and help you to get it answered. Another question from Allison. Are you using zero bus bar? Yes, we do. So this is one of the improvements we have done, zero bus bar. This is correct, yeah. Chris is asking about getting the panels. Yeah, basically you can reach out the distributors in Western Europe. Unless you have a big project, a big volume, then you can go directly. But this is something you need to investigate with the AIKO team in West Europe, like Belgium or Netherlands, France as well. Graham is asking, will there be a black version? Yeah, definitely there will be a black version, but a small panels, not on the 72 format. So on the 54 and 60 cells, you can get full black panels, mono and double glass. The warranty of these panels, 25 years product warranty, and for the performance, 30 years. Also, they come with standard long cable, 1.2 meters, and Stubli connectors. Talking about the power, maybe just to let you know, the 54 will be up to 85, 485, 490, and the black ones 540, 545. But again, you need to cross check with your local market to see what are the available. Chris is asking again, 770, how much volts? This is a good question. I need to review, but it's slightly higher than the regular panels. So yeah, basically when you connect these panels in series, you hit the limit like 1500 with less panels. Very good question, yeah. Altino's asking what's the zero bus bar. I think you need to read more about it, but in short words, basically you get rid of one one of the ways to collect the electrons. So basically, you reduce the electrical loss. But yeah, maybe you can look more, look deeper more on into that. Uh, Stick to deliver only panels or might be taken consideration. Let me just see. Chris is asking. So Chris, you are from Belgium, yeah? Yeah, we will keep doing and manufacturing solar panels. As far as I know, we don't do mounting system. We have a sister companies doing trackers. If you are interested, you can reach me out. I will put my email in the chat. AIKO.com. Yeah, so I just put my email there. Just feel free to drop me one email and I'll try to connect you with the right person. Let me go back. Okay, you like us to deliver only. Okay. Andreas is asking which time the Gen 3 comes for 60 cell module. End of March, April time. Yeah, but again, you need to cross check with your local distributor. One question Babi Tsitse. Okay, so what would be the output power of 2382113626 for the good question? I would say now we have 660 Q1 2027, so optimistically 10 watt more. So it will be 600, I would say 665, 670. Yeah, he's asking about the power limit of the 60 cells. 60 cells also has the same dimension of the panel we run through 2382 by 1134. So the power now 655, 660. You can get 670, I would say, by Q1 2027. One more question from Chris. I was late entering out. Yeah, Chris is asking, is it mono or double glass? So it is a double glass panel. I need to cross check if we have a mono glass, but basically it's a double glass panel. But if you need a mono glass with I think with a decent volume, we can always customize our panels. Another question from Belgium. Yeah, good. So Monique, yeah, so Monique is our colleague. Yeah, you can just reach Monique directly. Thanks, Monique. I think I'm done with all questions. So I would like to thank you for joining this session. If you have any question, just feel free to reach us, drop one email, and try to guide you to right person. And I wish you happy Friday and looking forward for the next session. Thank you for now, and yeah, bye everyone.